good morning, good afternoon, good evening. Okay, can you hear me now?
Yeah, it's a lot better. Thank you.
Can you hear me now?
It's kind of bad, the audio. Maybe you can try turn off the camera if maybe that could help.
The physical event is held today in New York, USA, and the virtual event is being held through Zoom today and tomorrow, that is 23rd and 24th May 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 8 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for the session. Mrs. Tuzuko Fetsu. Ma'am is a lecturer at the University of Botswana, specializing in data mining, information science, and information systems. Her research interests focus on cutting-edge technologies, including artificial intelligence, deep learning, computer vision, and big data analytics. She is dedicated to exploring innovative solutions and advancing knowledges in intelligent data processing and analysis. Welcome to the session, ma'am. Would you like to share a quick opening remark with us?
Hello everyone.
Yeah.
Unfortunately, my lighting is not very good. I don't think my camera would work, so I'm going to leave the camera off.
It's okay, ma'am.
I'm excited to be part of this session. Looking forward to fruitful interactions and feedback for the presenters. Thank you.
Thank you so much, ma'am. I would also like to introduce you to our Dr. Beaton Mishra. Ma'am is currently working as an assistant professor in the Department of Computer Science and Engineering at Techno International New Town, Kolkata, West Bengal, India. She has served as a reviewer in many peer-reviewed journals and conferences. Her main research interests include optimization techniques, deep learning, evolutionary algorithms, and soft computing techniques. Welcome to the session, ma'am. Would you like to share a quick opening remark with us?
Thank you, Anshika. Thank you for the nice introduction, and we look forward to a very interactive session today. I welcome you all abroad. Thank you.
Okay. So now it's the time to get started with our sessions. First, I would like to have Ernesto to present the paper titled A Case for the Dangers of Predatory Journals and IA Tools in Conjunction for Researchers. Are you there?
Hi, I'm here.
Yeah, you may please begin with the presentation.
Okay, let me share just one moment. Could you please confirm that I'm sharing?
Yes, you are sharing your screen and we can see it clearly.
Okay, so I will begin now, okay?
Yeah.
Hi everyone, my name is Ernesto Rivera and I'm here to present you my research paper that is titled A Case for the Dangers of Predatory Journals and AI Tools in Conjunction for Researchers. So, predatory journals are a kind of publishing houses that aim to take the money from researchers and inexperienced authors without providing any value or any peer review process. And in the current context of large language models, right now we are in a situation where it is very easy to generate low quality papers that can be published in this kind of journals. So the aim of this presentation is to worry researchers about the dangers of falling for one of these traps. The contents of my presentations are the following. I will be first giving a brief introduction about predatory journals and large language models. Then I will go in a little bit of depth about predatory journals. I'll be speaking about the use of large language models in current research. I'll be performing a brief analysis and I'll be finishing up with some conclusions. So as an introduction, the peer review process is essential for validating the correctness and methods used in a research. The peer review process can assess the research quality. It is performed by publishers before publications where the study correctness, method validity, and, and value of the research is evaluated. Conventional journals require publishing fees for it in order to perform the peer review process and for covering publishing costs. So journals get revenue from access costs to the published papers, and these costs are usually very high. This is inconvenient because not all researchers are able to afford that cost and don't have access to reputable science publishers. As an alternative, the open access journals were born, where published articles are available at not cost at all, so readers will not be charged for accessing the information, but authors must pay a processing fee. Nonetheless, there has been wide evidence of several open access journals that provide poor, incomplete, or no review process at all. Several of them are just focused on getting the money and fees from the authors. In the publish or perish model that is present in several academic and research institutions can create a bad incentive where authors and academics, in order to get their work published, could end up falling for a badly peer-reviewed journal or a predatory journal. So predatory journals are journals that charge authors with high fees without providing adequate editorial and publishing services. There is an author a bill that provides several criteria for identifying this kind of journals. I'll be speaking about a little bit more about those criteria in the following slides. One of the main setbacks of detecting a journal as a predatory is the need for human intervention. A person should evaluate if a journal is predatory or not. There have been several tools that have been developed in order to try to automate this task, but they need constant update and maintenance. So this and in the context of large language models can become a risk because we can end up with fast produced papers that could be published in non-reputable journals. This can tarnish the reputation of our researcher. So predatory journals. They are characterized to try to mislead and scam researchers into thinking that the journal where the research article is being published is a peer review valid publishing house. They employ several unethical tactics, like using names similar to those of reputable journals, having a below acceptable peer review process or that could be absent at all, having not transparent publishing processes, aggressive solicitation practices, and extra fees that they don't inform the author. The publication is gonna be guaranteed by payment without checking any quality of the article being published. And an author with a valid research could be lured into spending money and publishing in this kind of journals through misleading, manipulation, misinformation tactics. And this can devalue their research, even if the research is well performed. So publishing in this kind of journals can severely impact the research reputation and is usually considered unproductive. So this pitfall must be avoided. There are several campaigns that aim to warn researchers about this situation. One of them is the Things Check Submit campaign that provide several steps that authors must follow in order to identify a journal as a predatory one. And there have been several efforts to test for rigorousness in journals and scientific conferences. Before large language models, the SciGen software was used to create to automatically create bogus papers that were semantically correct, but it contained nonsense. There are several cases where these papers were accepted for publication in scientific conferences and journals. This was one way to evaluate the rigorousness. Also, there have been efforts to provide fake credentials to an editorial role of a journal where the person is accepted as an editor and shouldn't be because their credentials were not adequate. So there have been these kind of efforts. Also, there are repositories of predatory journals that are available, but these repositories must be updated constantly. Also, we have the situation of large language models. We know these kind of tools are widely used for text generation, and there have been several cases of papers accepted for publication that were made entirely by one of these tools, even in conferences that were not deemed as a predatory ones. So right now it's very easy to create cheap and fast low quality papers. And low quality journals accept these papers for publication without any problem, and quality scientific conferences and journals could fall into thinking that a paper submitted was a valid research. There are several threats of using this kind of tools, for instance, false authorship and plagiarism, hallucinations and misinformation, and threats to jobs of real researchers and real editors. One example is that I use a ChatGPT to generate a paper about this specific topic. It created a very plausible text that seemed correct, but I didn't know if it was correct at all, or if it was plagiarizing something. So there are several risks of using these kind of factors. So I'll be providing a brief analysis of the situation. The publish or perish model generates allows incentive for academic researchers, where in several cases volume is valued more than the quality of the research. Predatory journals are a means of getting their articles accepted for publication. So it could be very tempting to send an article to a non reputable journal. But this could be counterproductive for authors as it will negatively impact their reputations. One should be wary of emails and solicitation of colorful paper that sounds too good to be true and has high impact factors, because it could be a
Sorry to
scam.
interrupt you, sir, but you have 2 minutes to conclude your presentation.
Oh, okay, yeah. One should be wary of the quality of science publications could be severely diminished with the rise of large language models, so one should avoid using these tools for creating papers. Also, there are several tools that are being developed in order to identify large language models papers, so we should consider that when we make publications. I'll be finishing up with the conclusions. So in this research, we want to warn researchers about the dangers of publishing in predatory journals. It is important to detect the red flags in a journal. The validity of the publication could be diminished and question if it was a real effort to contribute to science. And large language models can be used as a guiding tool for researchers, but it should be as a main mean to create complete articles. The science community should be on the watch for the risk factors that could tarnish science research and publication. And there is vast space to continue researching and developing more sophisticated methods for flying flow research, generated completely in LLMs, or detecting a publisher as predatory. That will be everything from my side. Thanks a lot for your attention.
Thank you so much for your presentation. Ma'am, do you have any questions?
I have a question. Okay, this was a very great presentation and very interesting topic. Do you have any method to identify if the paper has been written using LLM other than some particular softwares? Is there any technique to identify?
Yeah, as long as I was able to search, there are several tools, but these tools continue failing. There is always a new case of a paper that was done entirely by LLM, and the tool didn't flag it. I know that these tools are it is an arms race. As the tool detects text generated through LLM, the LLMs becomes better at making the tool to avoid detection. So it is kind of an arms race in this aspect.
Okay, thank you.
Thank you so much. Ma'am, do you have any questions? Okay. So we'll be moving on to the next presentation. Thank you so much for your presentation. Next
Thank
up,
you.
next up, we have Mohammed Madi to present the paper titled Adaptive Event Processing in API Gateways, a reinforcement learning approach for optimizing latency and throughput. Are you there?
Yes, I'm here.
Yeah, you may please begin with your presentation.
Sure. Okay, just confirm you can see my screen.
Yeah, I can see your screen.
Okay, good. Okay. Hey everyone, my name is Mohammad Mahdi Qobadi and I'm a PhD student from the University of North Texas. Today, I will be presenting our research on adaptive event processing in API Gateway, a reinforcement learning approach. This work explores how we can use reinforcement learning to optimize API Gateway for modern microservices architecture. Let's start to cover some bases. What is microservices? Microservices are basically apps broken down into a small, independent pieces that makes scaling and updating much easier. To make all these pieces work together, we need to use API Gateway as a traffic manager that direct requests, handles security, and balance the load across the services. We have made this system event-driven so services can communicate without waiting for each other, which keeps everything running smoothly even when traffic spikes. But what is the problem with existing API gateway and what makes them unsuitable for dynamic environment? First, they have a static configuration that cannot adapt to sudden change in workload. And second, they lead to inefficient resource use, uh, resulting in either underutilization or overload of system resources. Finally, they exhibit poor handling of mixed workload. That means where critical events experience delay due to low priority tasks consuming too many resources. To address these challenges, we introduced OptiGate, a reinforcement learning-based adaptive API gateway. OptiGate learns from experience and real-time metrics and dynamically adjusting processing strategy to optimize performance. It prioritizes the critical events while optimizing throughput for less critical ones. Our system continuously improves performance by adapting to change condition, ensuring the efficient resource utilization. Our work makes several key contributions to the field. First, we propose a hybrid processing model that provides immediate processing for high priority events while batching low priority in queue. Second, we introduce adaptive parameters tuning, where the system continuously learn and adjust parameters based on the real-time metrics. And finally, we provide empirical evaluation demonstrating significant improvement in both latency and throughput compared to rule-based system. The OptiGate system architecture consists of several key modules. The ingress module acts as the front door that receiving and validating and authenticating all incoming events. The event classification module that analyzes and sort event into two sections, the high priority and low priority. An RL controller, the brain of the system, uses a PPO algorithm to make real-time decisions to process the parameters. And the batch processor module handles the low priority events in dynamically sized batches for efficiency. The matrix controller continues monitoring the system performance. And finally, the dispatch, which routes the process event to the appropriate backend server. We utilize a proximal policy optimization algorithm for our reinforcement learning approach. The system uses a six-dimensional state vector, including CPU usage, memory usage, high priority rate, low priority queue size, and average high priority latency, and finally, average low priority latency. And for the reward function, we are considering latency maximization, minimization, throughput maximization, and resource optimization. And this approach provides stability, efficiency, adoptions, robust, and also performance in dynamic environments. Our adaptive batching strategy involves the dynamic adjustment of the batch size and the processing interval. High priority events are proceed immediately, while low priority events are grouped into optimized batches. An adaptive stabilization periods is used after configuration updates to ensure system stability. This strategy allows us to balance the trade-off between latency and throughput efficiency. Our experimental results demonstrate significant latency improvement. As you can see in the chart, for the high priority event latency was reduced from 146 nanosecond to 68 nanosecond, which is about 41% reduction. For the low priority event latency, decreased dynamically domestically from 5,548 nanosecond to 818 nanosecond, and which is about 85% reduction. And total average latency was reduced from 954 nanosecond to 476 nanosecond, and about 84% reduction. In addition to latency improvement, we also observed significant resource efficiency gain. CPU usage was reduced from 50% to about 9%, and it was around 38% reduction. For memory usage, remains same. So low priority queue size was reduced from 580 to 32. The batch size and the processing interval were adjusted to optimize resource utilization. And you can see the traditional gateway reached to about 100,000 fixed batch size, but our adaptive OptiGate reached to only 460. The key benefit of our approach includes reduction rate, latency, resource efficiency, adaptive configuration, and balance optimization. Critical events are perceived faster, leading to improved responsiveness, and also lower CPU usage result in better scalability and reduce operational costs. Real-time adjustment to changing condition ensure optimal performance in dynamic environment. And also improve performance for all event type, providing a balanced optimization strategy. And for the future research, we will include the integration of additional system metrics such as network latency and disk I/O. We also plan to explore advanced RL technique for workload pattern prediction. And also for real-world deployment in a diverse environment will be essential for validation and refine our approach. And finally, we aim to expect our approach to other microservices components. Thank you for your attention. And if you have any question, please feel free.
Thank you so much for your presentation. Ma'am, do you have any questions?
It was a nice presentation. I have a small question. That was software specific environment have you used for this analysis?
Yes, we are using cloud environment. So we had several
No, I
virtual
mean in terms of
machines.
GPU.
Excuse me? Can you repeat again your question? I just miss your voice.
I guess ma'am said in terms of GPU.
GPU, in
Oh,
terms of
oh
GPU,
no,
what is the specification?
no, it wasn't GPU. It was using the CPU and memory.
Okay, so GPU not required for this one, right?
For training, we use GPU. For training the model, we use GPU. But for testing, we only use CPU.
And no more question from my side.
Okay, thank you so much, ma'am. Any more questions, ma'am? Okay, so we'll be moving on to the next presentation then. Next up, we have Henry to present the paper titled Cloud Integrated IoT Framework for Real-Time Monitoring in Water Treatment Plants. Are you there? Henry, are you there? So moving on, we have SM Mizanur to present the paper titled Computing in a Trust-Triggered Cyber Physical Human System for Human-Robot Collaborative Manufacturing. Are you there?
Yes, I am here.
Yeah, you may please begin with the presentation.
Okay, give me a second.
Yeah, you may start.
So, do you see my slides?
Yes, we can see your slides.
Okay, so give me a second, I will start.
Sure.
Okay. So, thank you very much for introducing me. The title of my presentation is Computing in a Trust-Triggered Cyber-Physical Human System for Human-Robot Collaborative Manufacturing. My name is Mizanur Rahman. I am an assistant professor of mechanical engineering at Pennsylvania State University, Scranton, USA. So background and motivation, human-robot collaborative systems or HRC systems can be designed in different forms or configurations such as CPS, CPSS, CPHS, etc. For the CPHS, the entire HRC system is divided into three elements or components such as cyber, physical, and human systems. And the entire function of the HRC system is divided into three functional units such as communication, computation or computing, and control. This division can help design and maintain each element and each functional unit modularly, which can aid the design, maintenance, and control of the HRC system. However, literature lacks good examples of CPSs for HRC systems. Literature also lacks modularization of CPSs components and functions. And we know that a good basis of computing, communication, and control is necessary. For example, human-robot bidirectional trust can be a good basis of computing, communication, and control. However, human-robot bidirectional trust as a basis of communication, computing, and control in a CPA system has not been investigated yet. So considering this background and motivation, or considering the gap in the literature, or considering the limitation of the current research, we have determined the objectives of this research as to design a human-robot collaborative or HRC assembly in manufacturing system in the form of a CPSS, and then modulate a single function. We have three functions: computing, control, and communication. But here in this research, I will modulate only one function separately, that is the computing strategies and methods. And I will use human-robot bidirectional trust as a basis of such modulation of the computing strategies, and I will investigate how such modularization works, or how such modularization impacts the performance and human-robot interaction of the human-robot collaborative system. So these are the objectives. So I have designed an experimental human-robot collaborative system. Here, there are different Lego blocks. The Lego blocks represent the industrial components that the human and robot can assemble in an industrial setup. But here we are using only the Lego blocks, and these Lego blocks will be assembled, and a final product will be made. And in the human-robot collaborative system, the human and the robot will collaborate to assemble these Lego blocks to a final product. So this is the human-robot collaborative system that we designed for the experimental purpose. And based on an optimization method, we have allocated different subtasks to the human and the robot. That means we have divided the entire task into many subtasks, and we allocated or assigned the subtasks to either the human or the robot based on an optimization method. So then, bidirectional trust model. So we derived the bidirectional trust model as it is presented in equation 1 and 2. In equation 1, it indicates the human trust in robot, and equation 2 shows the robot trust in human. Here, for human trust in robot, we have two main parameters. One parameter is the robot performance, another parameter is the robot fault or error that the robot may make during the collaborative process. So we can use the speed or performance speed of the robot as the performance, and we can use the IMU or other sensor to measure the speed, and then speed can be considered as a performance parameter. And the fault, that means if the robot makes any fault or error or mistake during the assembly process, that can be used, that can be measured using the computer vision technique. And based on that, once we can measure it, after that we can compute the human trust in robot, and in the same way we can compute the robot trust in human. After that, we display the human trust in robot and robot trust in human in a screen of the computer that was used to control the robot, and we can also display this in the screen of the robot. So in this way, the status of human trust in robot and robot trust in human can be displayed to the human, can be communicated to the human. So you see that here there is a parameter called K. K is a parameter. K is the time step. So time step means the update time. After how many seconds the computation will be updated. So then in this, so that will be varied in this research. So then this is our, this is the CPA's configuration of the actual system. In the left side, you can see the actual system, and in the right side, So I configured configured this system in the form of a CPH, or cyber physical human system, based on the bidirectional trust. And it shows that the computation and communication and control direction and different units and different functions. So this is the CPH configuration of the physical system, or the actual system. So then experiment, we recruited 18 human subjects to participate in the experiments. So what we did, so we have three different experimental protocols or conditions. These are slow computing, fast computing, and moderate or reference computing. So these depend on the value of k. So when we put k equal 0.01 second, that is the slow computing. And when we put k equal 0.0, when we k equal 0.1 second, that is the slow computing. When we put k equal 0.01 second, this is the fast computing. And when we put k equals 0.05 second, that is the reference computing condition. So then for each computing condition, the human and the robot collaborated to perform the assembly tasks. And we actually all human subjects separately separately perform the assembly tasks for each protocol, and then we evaluated the performance of the human robot collaborative system based on a comprehensive scheme, and we used this evaluation scheme. So the evaluation scheme consisted of different parameters or different types of evaluation criteria. For example, assembly efficiency, assembly success rate, physical human-robot interaction, and cognitive human-robot interaction. So then these are the results. The table 2 shows the results of the impact of the computing protocols on the assembly efficiency and assembly success rate. So this table shows that the computing protocols or computing conditions or computing speed can impact the assembly performance in terms of efficiency and success rate. And this table also shows that the computing protocols or computing speed can also impact the physical human-robot interaction in terms of engagement and team fluency. And this table shows that the computing strategies or computing speeds or computing protocols can also impact the cognitive human-robot interaction for these manipulation tasks. So then, in conclusion, actually, it was in this research, it was demonstrated how a human-robot collaborative system can be configured in a CPH system or cyber physical human system, and how human-robot bidirectional trust can be used as a basis of computing in the CPH system, how computing can be modulated, and how it can impact the HRC performance and interaction. In general, the results argue for modular HRC systems through CPS configuration for gaining advantages in managing and controlling the managing communications control and computing separately. That means in this research, our objective was not to evaluate the performance of the HRC system, but our objective was to show that how we can modularly or separately manage or investigate different functions like computing, communications, and control. But here I only presented the modularization or modulation of the computing strategies. But in the future, I will also modulate the control and communication separately. And in this way, I want to show that if we design a HRC system in the configuration or form of CPHS, then we can modulate different functions separately. Different functions means control, communication, and computing separately. And this separate I think arrangement or separate management or modularization can impact the performance of the HRC system, and it can also give some advantages in terms of managing and operating the HRC system in comparison with the HRC system that is not configured in the form of CPH system or cyber physical human system. That means the main objective is to argue for the advantages for configuring HRC system in the form of a CPS system. So this is the end of my presentation. So if you have any question or comment, I will be happy to answer your question.
Thank you so much for your presentation. Ma'am, do you have any questions?
Yeah, actually, I have a question. The work is very nice and interesting, but you mentioned an optimization algorithm to divide the task into subtasks between the human and the robot, right? So, can you name
Yes.
that optimization technique used here?
It is a very simple and basic optimization technique. Actually, we published this research as a separate journal paper in mechatronics journal Elsevier. So actually, we use the cost minimization optimization. That means minimum cost function, not the minimum
Yes,
maximizing
and
the benefit, but
what is the cost function is how it is formed? What are
cost
the
was, for
parameters?
example, the timing to manipulate a part from one location to another location. So the timing was considered as the cost. That means higher timing means more cost, and lower timing means lower cost. And also any fault. So when they make any fault, so for example, if we assign a part to a robot, so then whether the robot makes a fault or not, and if we assign it to the human, then whether it makes a fault or not. So making a fault is a cost. So where the fault will be the reduced or the minimum, so then that will be be decided. So in this way, so we have different criteria. That means I forgot, but we determined different criteria that indicated the cost during the human robot collaborative system, and then we minimized the cost, and based on the cost minimization, we actually allocated the subtasks to the robot and the human.
Okay, thank you.
Thank you.
Thank you so much. Ma'am, any more questions? Okay. So thank you so much for your presentation. We'll be moving
Thank you.
to the next presentation now. Next up, we have Elena to present the paper titled Development of a Virtual Travel Assistant Using the GPT Model. Are you there?
Yes, I'm here.
Yeah, you may please begin with the presentation.
Hello. Hello, dear colleagues. One moment.
Yeah.
Yes.
Yeah, your screen is visible. You may begin.
Yes. Yes, it's okay.
Yeah, it is.
Okay. Hello, I'm Elena Nikolaevska. I'm senior researcher at the Glushkov Institute of Cybernetics of the NAS of Ukraine in Kiev, and I would like to present to your attention a presentation development of a virtual travel assistant using the GPT model. Modern technologies are becoming increasingly integrated into users' daily lives. One notable example is virtual assistant, which are growing in popularity as tools that help users access information more quickly and accurately. A key advantage of VAs is their ability to understand natural language, at least to some extent, and deliver responses in various formats such as links, image, or brief explanations. This natural language interface makes VAs especially useful for individuals with limited technical skills or disabilities, allowing them to interact with technology more intuitively. We would like to present and propose concept of virtual travel guide, Guide AE, based on artificial intelligence technologies. There are instant access to information, natural language interaction, availability, 24/7 personalized experience, multimodal communications, automatic translation, inclusive design, smart navigation, cross-platform access. Imagine a trip to unfamiliar places. An intelligent guide using geolocation reads your coordinates, identify nearby attractions, and upon your request, shares their history, unique facts, or exciting legends. This system combines the capabilities of artificial intelligence, navigation, and data processing to create a personalized search. The intelligent guide becomes not just a navigator, but a real companion and storyteller, offering timely information about nearly object and allowing you to gain new knowledge about unfamiliar place at any time. Intelligent search engine employs artificial intelligence and machine learning techniques to analyze large volumes of data and find relevant information. AI-powered intelligent search system can dynamically analyze user preferences, geolocation, and real-time contextual data to provide tailored travel recommendations. Intelligent search engine offers several key advantages. There are automation and intelligent data processing, integration of geolocation and real-time context, personalized travel recommendations, enhanced decision-making through AI, scalability, and contribution learning. This approach demonstrates how AI and machine learning enhance personalized travel assistance by combining natural language understanding, geolocation, and real-time context. Guide AI sets a foundation for next generation virtual assistant with applications extending beyond tourism to smart cities and location-based service. Let's consider the architecture of the Guide AI. Microservice architecture involves developing individual service that perform specific tasks and can interact with each other via APIs. This modular approach allows for easy scaling of the system, adding new features and maintaining high availability and fault tolerance. Microservice services can be independently developed, deployed, and managed, which enhance the flexibility and resilience of this overall system. The system comprises a mobile application for user interactions and a backend virtual guide service that performs intelligent search based on geolocation and generated speech response. Together, they enable seamless real-time virtual guidance. The intelligent search engine operates based on real-time input, including GPS data, a dynamically adjust search radius based on the user movement speed and specific user task. These parameters allow the system to collect and process comprehensive information about the user's locations and nearby points of interest. The mobile application includes a user-friendly interface that allows user to configure the guide and play audio message generated by the backend service. When the user is in motion walking through the city or driving a car, the mobile application triggers the guide with a frequency that depends on the speed of the movement. The application adjusts guide update frequency based on user speed. Every 2 minutes for walking, every minute for cycling, and every 30 seconds for driving, ensuring timely and relevant information. These intervals can be dynamically adjusted by calculation the user speed in real time using GPS data. The mobile application obtains the current coordinates of the device using GPS, GSM, or Wi-Fi. It then makes an API call to the backend service to start the guide task by invoking post-run guide. The backend service provides the following API endpoints: get status used for health checks to ensure the service is operational. Post-run guide starts the execution of the intelligent guide task and it takes following parameters: latitude, longitude, radius, language. Get job result, return the results of the guide task, and get download file name. The guide task is responsible for generating a human-friendly audio recording that describes the user's current location and interesting places within a specified radius. The task workflow includes the following steps. First is search for nearby points of interest using the Google Place API. The next caching mechanism generate human-friendly description using OpenAI GPT for or convert text to audio. The generated text is converted into an audio file using Google text-to-speech. And the system returns the audio file name via get job return job ID, which the mobile application download using get download file name and place. This system dynamically adapts and updates frequently and provides engaging location-specific audio content, enhancing the user's experience in real time. The prototype of Guide AE comprises solely a backend service designed to function as a virtual guide for Kyiv, Ukraine, by generating and delivering audio files. The description message generation utilizes the GPT-4o model to produce textual content for a virtual guide detailing location and points of interest. Part of the program code utilized to analyze the user task using GPT is on the slide. Interaction with GPT is conducted via an HTTP API with the temperature parameter set to 0.5, determined through experimental evaluation. These settings ensures the balance between creativity and coherence in the generated responses. The model has been trained on a diverse range of internet text, enabling it to perform various tasks, including task summarization, translation, and content generation. The Google Place API is employed to retrieve points of interest within a dynamically adjustable radius around the user's coordinates. This dynamic adjustment ensures contextually appropriate recommendations, improving user experience and interaction with the system. And for speech synthesis, the Google Text-to-Speech API is utilized in the prototype to convert textual description into natural sounding audio guidance. The microservice is developed as a modular Docker Compose application featuring a Flex-based backend, salary worker with Redis for background task processing, and Flavor-powered dashboard for real-time monitoring, all tested via Postman for seamless API interaction. The prototype was tested used real-world coordinates from various locations in Kyiv, ensuring the accuracy of geolocation-based recommendations and validating the robustness of the system. Presented here is an example of an intelligent guide service that provides a description of point of interest located at the coordinates of Kontaktova Square in Kyiv. You can see it in figure 1 to 3. This slide demonstrates the prototype in action. In the first example, the user selects coordinates and the system identifies nearby points of interest.
In the heart of Kyiv, where history and modernity intertwine,
for example,
lies a cluster of activated landmarks.
The second, one moment. The second, it showcases automatic location detections using GPS to find attractions in real time.
Nestled nearby in the vibrant district of Teremki, Kyiv,
For example,
test.
further development is devoted to enhancing user experience, mobile application development, personalization and adaptive learning, accessibility and multimodal interaction. Ultimately, the goal is to create a highly interactive, context-aware virtual assistant that not only provides secure information, but also replicates the engaging and personalized experience of a human tour guide. And we can make conclusions. A microservice-based architecture for the Guide A system has been proposed, enabling high scalability, flexibility, and fault tolerance. Integration of GPT-based A model, geolocation data, and adaptive learning mechanism has been implemented for real-time context-aware travel recommendations. The system delivers personalized suggestions based on user behavior, location, weather, and current event. A modular structure enables the easy expansion and seamless integration of services such as natural language processing and geospatial data processing. The platform includes TTS technologies and voice assistants to enhance accessibility and inclusivity. Multilingual interaction is supported through GPT's capabilities, allowing users to communicate in their preferred language. And guide a key innovation of Guide AE is in its ability to learn and adapt in real time by analyzing user behavior pattern and contextual changes. The AE system refines its recommendations dynamically, ensuring continuous improvement. This adaptive framework contributes to the advantage of intelligent search and decision-making system, demonstrating how AE can evolve based on real-world data. Ultimately, this work provides a framework for future AE-based virtual assistants that can be extended beyond tourism to fields such as education, cultural heritage, presentation, and smart city applications. Thank you very much. Thank you for attention.
Thank you so much for your presentation. Ma'am, do you have any questions?
No question from my side.
Okay. Ma'am, do you have any questions? Okay. So we'll be
I
moving.
have a quick
Yeah, yes, ma'am.
question. Okay. This is very interesting research, Elena. I'm even more interested that I'm coming from a tourist town, so I'm thinking something that will be really useful for tourists if I'm understanding the context correctly. So my question is, I saw you when you were talking about the app prototype and you were prompting it using GPS points. So I'm just curious as to why GPS points, and is there another option I can query or prompt it other than inputting GPS points? Assume maybe I'm just a lame person, I'm not familiar with GPS points.
I hear. Thank you for your question. I hear you very bad, but about GPS, in our prototype, we test it, of course, and we use two variants for prototype. We can put the coordinates, and our prototype, of course, can find our coordinates and propose interesting places near. It's depending on my how I go, by walking, by cycling, by car, and by radios. It depends on the radios. It proposed me some interesting place, if I understand you, because I hear you very bad. Yes.
Okay. No, it's okay. I was just like curious about is it able to? I'm assuming it's able to pick my location. So my question was on why did you specifically want it to be supplied with GPS points? Is there another way of asking it for assistance but not giving it GPS points?
Yes. We can use not only GPS, we can use also GSM or Wi-Fi. And in the future version, we plan to use TTS in all communication. It will be like speaking with you, you and me, for example.
Okay, thank you.
Thank you so much. Thank you so much for your presentation. So we'll be moving on to the next presentation now. Next, we have Alvaro to present the paper titled Predictive Model Based on Discrete Time Markov Chain to Analyze by Binaural Urban Noise. Are you there?
Yes, I'm right here, Anishka. Thank you very much.
Yes.
Is that South Africa flag? It's just because I'm Colombian. Oh,
Okay.
but that's fine. No worries.
Yeah. You may please begin with the presentation.
Yeah, let me go ahead and share.
Yeah, we can see it. You may please begin now.
Well, okay. All right. I believe you see my screen now.
Yes, we can. Yes, we can see your screen.
Just the slide, right?
Yeah, the first slide. Yeah, we can see
Full
that.
slide. All right, great. So, well, thank you very much, everyone, for joining today. Good morning here in Colombia. I am Álvaro Casanova from Universidad Distrital Francisco José de Caldas here in Bogotá, Colombia. It is an honor to present our research, our recent research at ICTIS 2025. And I'd like to first of all acknowledge the support from Colciencias, our research group G2, and of course my university, Universidad Distrital Francisco José de Caldas. Today, I'll walk you through a predictive modeling approach based on Markov chains applied to urban noise data captured through binaural sensors in Bogotá, Colombia. So let's begin by understanding the motivation behind this study. Okay, so noise is more than just annoyances. According to the World Health Organization, continuous exposure to noise levels above 65 decibels can cause hypertension, stress, and sleep disorders. In Bogotá, studies show that over 2/3 of urban zones surpass acceptable noise limits during the day, and yet current tools like noise maps are static. They're updated every 4 years and fail to reflect daily fluctuations. Definitely, our cities needs more data models that account for how noise evolves every minute by minute. So talking about the project background, this research was founded by Colciencias, like I said, as part of the national initiative to enhance urban monitoring infrastructure. It is embedded with the work of G2 research group at Universidad Distrital. Our team built and installed 7 custom monitoring stations with binaural microphones that emulate human hearing, right? That's basically it. As you can see in the picture, that's the basic model. These devices recorded over 4,200 audio samples, each 5 minutes long, over the course of 47 days. So most environmental noise monitoring today focuses exclusively on the sound level, which is LEQ. So we're going to talk about the problem here. So basically what happens is that they ignore where the sound is coming from, how people perceive it, or how it is likely to evolve, right? We also notice a disconnect between classification tools and predictive models. And this research bridges the gap by combining machine learning for sound tagging with stochastic models that can simulate noise behavior over time. So here is an overview of our methodology. First, we develop IoT-based binaural sensors to continuously capture urban radio, as I mentioned in the last slide. Each recording was sent to the cloud, where it was processed to extract spatial and energy parameters like LEQ and AICC. Then we run inference models that classify the type of noise, be it traffic, speech, or alarms, for example. Those were completed in a previous work. Finally, we use these label samples to construct a discrete time Markov chain which models the evolution of noise conditions over time. Now, basically the methodology here. Next, talking about sensors and architecture. So here's kind of the landscape, the map of Bogota here in Colombia. What we did is just distribute 7 binaural sensors or stations. They were installed, like I said, in 7 strategic locations in Bogota and operated continuously for 47 days. Each device captured a 5-minute recording every 5 minutes, resulting in more than 4,200 high-resolution audio samples. And they were powered, every station was powered by solar energy and streamed data to the cloud using Amazon S3. So we're going to talk about the classification pipeline. Once the audio was in the cloud, right, like I said, in Amazon S3, we run 2 processing pipelines. The inferencer used machine learning to assign probability weights to possible sound sources like engine noise, sirens, voices, music, so on. Meanwhile, another application called Sound Metrics extracted technical parameters like LEQ for energy and AICC, WAICC for spatial coherence. The result was a structured data set where each audio file was represented as a vector of numerical descriptors and sound probabilities. We're gonna just take a look into data structure and preparation. So after processing, we ended up with a clean data set of 4,279 instances. Each row represented a single 5-minute recording with over 30 columns, including timestamps, classification tags, and spatial metrics. After that, we normalized the values and grouped fine tags into broader categories like traffic or voice to improve interpretability. This was the foundation for assigning composite states and fitting the Markov chain. So you may ask, okay, why stochastic instead of deterministic? The answer is urban noise isn't deterministic. It fluctuates due to human behavior, traffic surges, and even weather can affect. So a stochastic point of view or stochastic models are designed to handle that variability. Markov chains in particular help us understand the likelihood of transitioning from one noise state to another, something fixed equations can't do, right? It is a model that breathes with the rhythm of the city. That's what we call it. So we're gonna start with the probabilistic characterization. So we began our probabilistic analysis by plotting distributions, of course, just to understand what type of data we have. So starting with LEQ, we realized it ranged from 49 to 87 decibels, with peaks aligning with, of course, rush hours here in the city. AICC show a multi-module distribution. Most values cluster around 0.2 and 0.45, indicating different noise sources structures, right? Interestingly, we found a moderate negative correlation between AICC and LEQ, suggesting that spatial coherence tends to reduce overall noise energy. These insights were critical in modeling how acoustic states behave. And we're going to talk about the acoustic states. So to make the modeling manageable and meaningful, we define composite states. Each state is a combination of noise intensity category, like for example, low, medium, or high, based on the LEQ level, and sound type, which is such as traffic or voice, and so other categories we have. So after that, we grouped the detail tags from inferencer into 7 broader categories. That resulted in 21 distinct composition or composite acoustic states. So these states serve as the basic units of transition in our Markov model. Next, we analyze how frequently the acoustic environment shifted from one state to another. So we're talking about transitions. By scanning through the sequence of labels across the dataset, we build a 20 by 20 matrix. Each cells represent the probability of moving from one state to another in the next time step. We normalize each row to ensure it represents a value probability distribution. One key observation is the matrix is sparse. Most transitions occur within the same state, showing a strong persistence. We ran a simulation using these metrics, as you can see. We simulated 500 steps, which
Sorry to
correspond to,
interrupt you, but you have 2 minutes to conclude your presentation.
absolutely. So we simulated 500 steps, which correspond to around 41 hours of real-time noise conditions. We started from the state with the highest outbound transition probability, essentially the most likely starting point. Each subsequent step was determined by using stochastic sampling from transition metrics. And this approach gave us realistic sequence of sound types and intensities, mimicking how noise conditions evolve day by day. So this is a simulated acoustic sequence. And as you can see, these transitions mirror real-world phenomenon like morning rush hour or nighttime quiet. The Markov model effectively captured both stability and variability in urban acoustics. So to validate the model, we compared its output to real data using several metrics. The results were striking. Our simulated sequences align with actual data in over 90% of cases. And this confirmed the model's capability or capacity to accurately replicate the temporal evolution of noise in Bogota. In conclusion, discrete time Markov models or Markov chain offer a powerful tool for modeling urban noise patterns. By using real sound categories and noise intensity, we created composite states that reflect the real experiences. Our use of binaural microphones added spatial perception to the model, which is readily considered. And ultimately, this approach connects advanced acoustic monitoring with practical tools for cities. So we have a couple contributions and innovations. So by combining machine learning-based sound classification with Markov chain stochastic simulation, the model captures both the variability and complexity of urban soundscapes. Most importantly, the model demonstrated strong predictive alignment with real data, achieving over 90% correspondence in simulated acoustic patterns. We have future directions. So looking ahead, we see this as a foundation for more complex systems. One option is using stochastic differential equations, which allow modeling in continuous time. We also want to feed in live traffic and mobility data to improve forecast. And finally, we plan to test this approach in different cities and soundscapes. So that's pretty much for today. Thank you very much for the time. Thank you for the support of Colciencias, Gitude, and Universidad Distrital.
Thank you so much for your presentation. Ma'am, do you have any questions? Okay, I guess no questions then. So we'll be
Thank
moving.
you.
Okay, so we'll be moving on to the next presentation. Next, we have Ramiro to present the paper title, Safe Journey, Enhancing Road Safety Education and Promoting Behavioral Changes Through a Mobile Application. Are you there? Ramiro, are you there? Okay. So we'll be moving on to the next presentation. Next, we have Gary to present the paper title, The Development of Predictive Artificial Intelligence Analytics in the Financial Service Sector, a case study of multiple companies.
Okay.
Are you
Hello,
there? Yeah.
I'm here.
Yeah. You may
Do
please
you hear
begin.
me?
Yeah. I can hear you. You may please begin with your presentation.
Okay.
I'm just checking whenever I can see the screen. Yeah, I can see your screen now. You may please begin.
Okay. So good evening, everyone. So my name is Giri Prasetyo, and right now I'm a master student in Binus University in Jakarta. So our research paper is about the development for predictive AI in financial service sector. So this is a case for a multiple company, and our research is just for to look up how far it goes in the field. So here, what can I display for here is right now in the current situation, the AI is already really developing, really looks really far away, and we know it already assists our daily life. And of course, in the financial institution, it's already a big things. And of course, here in Indonesia, where the financial institution is really strict with the regulation, there's a strength and what we can call it a little bit drawbacks because of the regulation, how AI can be implemented in Indonesia. And we can see the implementation of the AI here. So what can I seek here in Indonesia? There's a couple of companies that are already developing these AI things for their actual use for customer service and product development, even for the project management. And what is the things that can be do with this AI things? Right now, they can do the real-time forecasting, risk assessment, process optimization, even though with the transaction process that can be cut off with the AI. And in the project management that I've been researched, so there's in McKinsey reports there's an underinvestment. How far the AI already developed in financial institution? That's just a 12% of the budget where they are allocated, and for the digital budget, there's just a 20%. And this in Indonesia having a little bit high cost of the implementation, and not all of the financial institution implement this what we can call it this technology. So how can I conclude and the methodology of my research? So the first thing, it is a qualitative multiple case studies, and the data collection, it is a bilingual and semi-structured Zoom interviews. So the sampling are the purposive and expertise driven, and it consists of 5 respondents. How can to be analyzed? So the first things, we are making the transcript, and then we are putting in the end vivo, and each of variable and each of topics will be concluded as the thematic coding, and we know how far the developing or the topics main or the impact in the AI of the project management in each of financial institution. And the outcome is the frameworks of AI implementation, resource constraint and settings, and all of it, how is it going in the real field. So the results that I can choose here, not I can choose, the result here that actually I can display, the respondents is 5% that in the strategic position in each company. So there's an HRIS manager, IT manager, technical analyst, project manager, and auditor manager. And each is in bank and the micro lending organization. So how is the result? So in the project management, there's I can conclude for 4 tests that already improve or already can be go in the financial institution. The assess and manage risk, or we can say the risk prediction. For the implementing risk management strategies, it's actually a huge loop for the implementation of AI. So it can tell that whatever the manage of the new project or the new product, they can comparable with the risk and the profit about it, or whatever it can call, or maybe they can also prioritize risk. So maybe there's a huge loop in the budgeting or something else. There's a problem. They can just straight say that there's a risk in here and risk in there, just like that. And for the identifying risk, there's a 25% effect in the implementation of the AI. So what I can say that we can seek how this AI can really identify all of the possibilities. And then the next one, for the budget management, resource and allocation in project management. So the estimate budget and resource, it is the main huge impact for the AI. They can really estimate budget and can predict how far it goes for one and another project, and can compare with another project that already implemented. Maybe they are taking data in the internet, and then they are seeking for the previous project, and can seek for the what we can call that. We can predict how far or estimating the budget, and of course it can also conclude the anticipate challenge and manage the resource efficiently. So yes, optimization. And the third one, for the project deliverable and quality planning and management. So for the two variables, it's not really have an impact, but I can say that even for in the project and comparing one in another things, it can be set a quality standards even for the coding or for the project process, or even though a whole with another projects, it can setting all of it with the what we can call that, with the a significant objective data. So the standards or the ongoing projects can be monitored, like in before the variable before can be monitored or can be improved with the even with another scope of the project is not really in a good way. That's why it can make in a good a quality standard for another comparing scopes of the projects. And the last one, actually we know about this. So the automation of financial process in this in the institutional process, of course, it having a huge impact in transaction process, and of course the data entry and compliance verification. What I can say that in these things, in these AI things, there's a huge impact in the assess and manage risk, and there's an ongoing too in the budget and manage efficiently. So the conclusion is this AI actually enhance for the project management efficiency in Indonesian financial institution sectors with in the 5 banks, and from the 5 expertise that already have been going through with this AI implementation. And of course, the risk management, budget estimation, and resource allocation is actually improving. For the automatic complex text, actually the system can be collaborating one and another and setting a quality standards, so it can going through how far the example and seeing the project going and risk mitigation through real-time insights. Of course, the end of it, the AI-driven automation financial process actually make it the transaction process smoother and minimize the human error. Of course, excellence reporting and underscoring transformative potential optimizing too. So that's all for my presentation. Thank you.
Thank you so much for your presentation. Ma'am, do you have any questions?
No question from my side.
Okay. Ma'am, do you have any questions? Okay. Then I guess we'll be moving on to the next presentation. Do we have Henry to present his paper titled Cloud Integrated IoT Framework for Real-Time Monitoring in Water Treatment Plants? Do we have Henry? I guess we do have.
Yes, I'm here. Just
Yeah,
give me 1 second, please.
yeah. You may please begin with the presentation. Yeah, we can see your screen. You may please begin now.
Okay. Okay, thank you very much. Sorry for the technical problems. Good morning. I'm pleased to present our work on a cloud-integrated IoT framework for weather trimming monitoring. This solution addresses the limitations of current systems with real-time, security, and scalable monitoring. My name is Henry Roa, and thanks for your attention. So, what is the motivation? Yet many facilities still rely on manual inspection of the SCADA systems, which are expensive, error-prone, and not scalable. Additionally, they are not affordable for small towns in developing countries such as Ecuador. So, what's the problem? SCADA systems have high entry costs and require specialized staff. They don't offer true real-time data and often lack robust security, especially in small remote plants. So what is the research objective? We aim to design a secure cloud-integrated systems that could continuously monitor weather quality, alert operators to anomalies, and do so affordable and reliable. Design science research. We use the design science research method focusing on interactive problem solving, identifying issues, defining goals, designing, simulating, evaluating, and sharing results. System architecture. Here is our system. Sensors collect data, the ESP32 preprocess and sends it via MQTT to the AWS IoT core, which stores and analyzes it using time stream and displays it via Grafana. So what are the key parameters that we monitored? Our framework monitors key quality indicators such as pH, turbidity, and flow rate. These sensors comply with regulatory accuracy standards and provide reliable and continuous data. The communication protocol. We choose MQTT for its lightweight and reliable communication model. All messages are encrypted using TLS, and each device is authenticated to prevent intrusions. The cloud integration. AWS provides a scalable backbone. IoT Core manages secure communication, time stream stores structured sensor data, and Grafana provides real-time dashboards. Dashboard visualization. The dashboard shows live sensor values, system health, and alerts. Operators can monitor the system remotely and respond proactively to anomalies. Simulation setup. We simulated sensor data to validate system performance. Network drops were tested and the system buffered and recovered data correctly. It scaled to 50 sensors without any loss. Performance metrics. The results were excellent. Low latency, high reliability, and near constant uptime. MQTT reduced bandwidth by 40% compared to HTTP, making it ideal for industrial IoT. Anomaly detection. Anomalies like a pH drop to 2 triggered immediate alerts. This real-time detection gives operators a crucial window to act before issues escalate. Security features. Security is foundational. Beyond TLS, we implemented device authentication and access roles. These measures outperforms SCADA's outdated security. Cost comparison. Cost is a major barrier to monitor. Our IoT system reduces infrastructure and maintenance costs while offering superior capabilities. Conclusion and future work. This framework is a solid foundation. Next, we aim to integrate artificial intelligence, enhance edge capabilities, and use blockchain for secure tamper-proof records. Thank you very much. I would love to hear your thoughts or questions. Feel free to reach out for further discussion or collaboration. Many thanks.
Thank you so much for your presentation. Ma'am, do you have any questions? Okay, I guess no questions then. Thank you so much for your presentation. Do we have Ramiro to present the paper? Do we have Ramiro to present the paper? Okay then. I would sincerely like to thank our authors for their excellent presentations and contribution in the session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. The participation and publication will be live within 6 to 7 months. Kindly cooperate with the team of ICTIS 2025. Before ending this session, I would also like to thank our session chair for chairing this session. Ma'am, this is a token of appreciation from our side. Would you like to share a quick closing remark with us?
Okay. Just to thank the presenters and everyone who was here for the informative presentations, and just appreciate the valuable feedback that was shared between the presenters and some of us who were asking questions, and I'm grateful for the fruitful interactions. Hopefully we'll interact again in future conferences. Looking forward to building connections from here. Looking forward to possible collaboration. Thank you.
Thank you so much, ma'am. This is a token of appreciation on the behalf of the whole team of ICTIS 2025 and Global Knowledge Research Foundation and partners. I would also like to take a moment to thank our session chair, Professor Beetan Mishra, for chairing this session. Thank you so much, ma'am. Would you like to share a quick closing remark with us?
Thank you, Anshika. Thank you for the very nice session. And all the presenters, I want to thank you for this very interactive and informative session. And I look forward to ICTIS 2026 next year. Thank you.
Thank you so much, ma'am. This is a token of appreciation on the behalf of the whole team. So before ending the session, I would like everyone to kindly switch on their cameras for a quick snapshot. Everyone, kindly please open your cameras for a quick snapshot. Thank you so much, everyone. Thank you so much for the session.
Thank you, Nishka. Bye.
Thank
Bye,
you.
y'all.
Thank you very much.
Everyone.
Bye-bye.
Bye-bye.
Thank you. Bye.
Thank you. Bye.
Bye-bye. Thank you.